The next topic is JDK tools. So mostly we are going to look into performance, mostly for performance related tools in this presentation. So first, we're going to take a look at JPS. So the JPS lists the JVMs that are currently running and including embedded VMs. Okay. So you can let's actually try this guy. So we say JPS. And so we have two processes, and if you say JPSL, and you have more information. Okay, so that's JPS. And JInfo, it basically gives you a configuration information from the running VM or core file. So basically we can say JInfo, and then you provide a PID. Okay, I am going to actually use I'm going to run like a visual VM, JVisual VM. Something like this, so that we have something that we can identify, and then we are going to okay, so we have a visual VM, and then so if you say JPS, we have yeah, so this is the main. Okay, so let's say JPS.L. Okay, yeah, so this 8,000. So that's the one that is actually running this JVisual VM. Okay, so we can say JInfo, and then we provide process ID like 8,000. Okay, oops, matching 8,000. Wow, unsaved. Cannot load. Oh, this is interesting. Okay, so I'm gonna just say JInfo. Let's see what yeah, looks like this is actually some issues with the latest version of JDK. So I'm going to actually go to Java, and let's use 0.5. And let's see, I'm going to, so even Visual VM, I'm going to start from 0.5. Okay, so here, go to bin, and then JVisual VM. Okay, so now I'm going to go Java, and let's use the 0.5. Okay, and go to bin, and now say JPS.L, and now let's see, we can ask JInfo, and this process. Okay, that works better. So I don't know what's going on with the 8.25. Okay, so I'm going to stay with the 0.5 for now. Okay. All right, so that's JInfo, and you can also get the JStat. So list the statistics of given VM, so like a class loading information, garbage collections, hotspot compilation, and so it does provide lots of information. So you say JStat and GCUtil. So in fact, you have a bunch of options, and then you provide a process ID, intervals like a 1,000 milliseconds. So I want to actually get the information every second, and the number of samples. So it's going to actually display 10 of those. So if you say JStat, that GCUtil, and the process ID is what? Let me just get the JPS one more time. JPS.L. So we only use 1150, this guy. Okay. So we say JStat and dash GCUtil, and the process ID, and we want to have an interval 1 second, and number of samples will make it 20. Okay, so it will just display 20 of those. So these are a bunch of informations certainly you can take a look at the documentation, which we are going to do in the hands-on lab. Okay. JStack prints the stack traces of all the threads attached to a virtual machine. Okay, so and you can also use -L option to detect deadlock the detections, which we are going to actually play around in the hands-on lab, and -F to force stack if VM is hung. If you happen to have a JVM that are hung, then you can still use the JStack, use the -F. Okay, but it works with only Solaris and Linux, unfortunately. Okay. So I cannot do that. So this is the sample output, JStack. So let's say JStack, JStack, and process ID. Yeah, so this is a bunch of information. It actually gives you all the information about the thread. Okay, so let me just see the first. I'm going to just use some more. Okay, so these are the threads. Okay. And I should be able to use -L option -L. Yeah, so the some deadlock related threads. Okay, so that is JStack. Okay, so this is the sample output of JStack. JMap prints memory-related statistics. So it basically contains a detailed information about overall memory configuration. So capacity, freed, and used. Okay. So JMap sample output. So again, you can say JMap, and like this, and they give you detailed information. Okay. We are going to do some more fine-grained exercise in the hands-on lab. So this is Solaris and Linux, and this is on Windows. hprof heap dump. So we already talked about the heap dump format, right? Okay. Underneath is actually using JVM-TI to get information from the running JVM, and so it contains information about CPU usage, heap dump, thread state, and start at command line. Okay. And you can specify the format for JHat analysis. So you can actually create a heap dump, and then that could be analyzed by using another the command line tool called the JHat. Okay, so useful option heap all and CPU sample, and then you can dump on the heap dump will be created on application exit or control \. JHat is, we have actually used Eclipse Memory Analyzer and NetBeans Heap Worker to analyze the heap dump, right? You can also use the JHat to analyze a heap dump, okay? So basically you can say, yeah, first of all, you are going to create a heap dump by saying JMap and dump, and this is the name of the dump file. So when you run the JMap, it will create the dump, heap dump. Then you're going to use the JHat. So JHat will parse the heap dump file, and then it will actually, run the web server so that you can access the result using a browser. Okay, so it shows all the classes and objects, all classes information, objects on the heap, instances, and object reachable from the root set. So obviously this is not as powerful as Heap Worker of NetBeans or Eclipse Memory Analyzer. But it's actually available on the command line. Okay, so when you happen to have a situation where you have a heap dump created in the production environment, and you certainly do not want to install NetBeans or Eclipse Memory Analyzer, but in that case you can just use a JHat because it's it comes with a JDK. Okay, so it could be actually used the very quick and easy access for heap dump analysis. JHat also has what is called the object query language. It's like SQL-like language that you can use to find more information as a query. For example, you can do something like this. I want to find all string instances whose data size is greater than or equal to 512. So in that case, you can use this command, select S from java.lang string where S and where size of S value is greater than 512. It's almost like SQL, right? So you can run this command inside JHat browser, and you should be able to get the result. This one is find all URL instances that is referenced by 2 or more objects. So you can certainly actually have a fine-grained query operations using the OQL. So we're going to actually do this one in the hands-on lab. Okay, so let's do exercise 1. Oh, I didn't unzip it. Okay. Okay, so we are going to JDK tools. Oh, no. Oh, I was actually looking at the, okay, so I'm going to go to the labs and JDK tools. Yeah, okay. And this is the lab documentation. Okay, so we're going to do exercise 1. By the way, you can get the more detailed information on these tools if you click the detailed tool description section of the Java, and you should be able to, get more information about each of these commands. Okay. All right. So now JDK tools here. Yeah. So we're gonna actually run either Anagram, or you can run JVisualVM. Whatever Java application you want to run. Okay. So in this case, we just build the Anagram, and again, we are running as a separate application. So once you build it, you should be able to capture this guy and then run it. Okay. Then then we can actually see. So we did a JPS, right? So JPS, JPSL, and you can actually find a lot more verbose information by using -LV option. Okay, and JConsole. Yeah, so JConsole comes with JDK as well, so it actually gives you more detailed information. JConsole is like a JMX. The JMX. So I'm going to use a Visual VM. Is the JMX client. So whatever management information on the connection. Yeah, connect. Oh, looks like yeah, it's because I was actually using the incorrect version. So let's again go to Java, and I'm gonna actually use the 05 version. And go to bin, and then JConsole here. Okay, so Visual VM, connect, cloud access, NQ access. Okay, so you can get the memory usage, thread information, classes being used, VM summary, and you can also even actually have mbins. Okay, so this is actually related to JVM. Okay, so JVM comes with a lot of management information, like logging information as object name, logger names, and things like that. Okay, so JConsole comes with the JDK. Okay, so that is JConsole, and yeah, so I showed you all this, and JMap. So JMap, you can you can actually create heat dump file. Okay, so here let's the JPS. Okay, so I'm gonna actually create a heat dump file. So JMap, and what you want to do is you want to specify the heat dump file format, and the file that you want to create. Okay, so I'm gonna just capture this guy here, and then you provide the process ID, so which is in this case 11.5.84. Okay, so now it creates heap dump file on the, in my case, temp my heap bin file. So let's just see. So if I say this guy, yeah, so you can see it has been created 3 or 4 seconds ago. Okay, all right. So now you should be able to read this heap dump file using NetBeans Heap Worker, or you can read using Eclipse Memory Analyzer, or in this case, we are going to use a JHat later on. Okay, All right. So here you can actually use you can actually read this heap dump file using Eclipse Memory Analyzer. Okay. So you can also actually have histogram information. Now we are going to use a JHat and perform OQL query. Okay. So if you say JHat dash help, you have a bunch of information. Now what I'm going to do is I'm going to read heap dump file using JHat. Okay. So I'm going to say JHat heap dump file. Oops. JHat and C temp and my heap.bin file. Okay, so what it'll do is that it will analyze the heap dump file, then it will start the HTTP server of its own, and then it lets you know which browser location I can access to see the result. Okay, so you can see HTTP server is up and running, right? So it's actually starting on port 7000. Okay, so what I can do is I can go to HTTP server, HTTP localhost 7000. Okay, so if I go over here, you can see all informations. These are all classes, packages, and things like that. Okay, so now what I want to do is to perform. So you can actually click this guy, and you can see more information, instances and references. Yeah, so these are reference for this to this object. Okay, now we are going to actually use the OQL. Okay, so at the end you can actually say execute the local query language OQL. Okay, so I'm going to actually have the side by side. So localhost 7000. Okay, it should be HTTP localhost. Okay, so I'm gonna have this one. Oh, so it did. Okay, so I go back here, and if you go at the end, that is the OQL. Let's see if I can go to the end. Yeah, here you go. So execute object query language. So click this guy. Now you should be able to enter some OQL. So the things I want to do is maybe I want to select S from Java string S here. So basically I want to find all string object instances whose size is greater than or equal to 512. Okay, so I'm actually using Visual VM. In your case you're using Anagram. Okay, so whatever is fine. Okay, so I might actually have a different result than what you see on the documentation. Okay, so this is being performed, and if there are any string objects which is greater than 512, it will list it here. Okay, so in this case, in this case it's anagram. If you click this guy, and you should be able to see this object. This basically this is detailed object information. Okay. Let's see whether, yeah, okay, so it comes back with, so I'm going to just select this particular object, and it contains an object whose string object which is actually greater than 512 bytes. Okay, JStat is for, so JStat is actually for the information, the statistics information. Okay, so JStat and GC information. Yeah, so we have actually tried the GC util, right? So this is basically displaying garbage collection information, garbage collection related utility information, GC news. So a bunch of information you can actually get. Okay. The last one is a JStack command line utility. Attach the specified process or code files to print the stack traces. Okay. So this is something we have tried as well, right? JStack, and then you provide the process ID, and the stack information is available. Okay, so right now it's 10 minutes after 3 o'clock, so we are supposed to be done at 3:30. So we are going to actually call, I'm going to give you guys about 10 minutes to do this exercise 1, and then we might actually call it a day. Okay, so let me just, we'll actually start from the next topic. Okay. We have covered so far command line tools that come with JDK, such as JMap or JHAT, JPS, and JStat, and things like that. We are going to cover a few more tools that come with the JDK. This time we are going to look into visual tools. So the first one we are going to see is JConsole. Again, it comes with the JDK, so you don't need anything else. So it's a graphical console that enables you to monitor and manage Java applications, and it's based on plugin system. And in fact, you can install a few plugins, and you can create your own plugins as well to JConsole. It provides information on memory usage and garbage collection activities, and it provides information on threads and their stack traces and locks. We are going to see how we can detect deadlocks between threads using JConsole later on in the hands-on lab. Object pending finalization and runtime information such as uptime and CPU time. And you can also find out JVM information such as a class path, properties, command line arguments, and things like that. Another tool that comes with a JDK is a Visual VM. So Visual VM is based on NetBeans platform. So it looks, it looks similar to NetBeans. It's also based on plugin system, just like a NetBeans, and it does have a few plugins you can use, such as a Visual GC. Visual GC is a visual tool that you can see what's going on in terms of garbage collection, and you can add JConsole plugin to Visual VM as well. So you can have a JConsole functionality within Visual VM. Thread dump analyzer and profiler. So it comes with a little bit of profiling capability. It's not as powerful as NetBeans full profiler, but it has some of those. It runs only on JDK and after. So if you have JDK5, Visual VM is not available. Okay, so we are going to actually exercise JConsole in this topic, and we have another topic that covers Visual VM. So let's take a look at the exercise 2. In this exercise is memory consumer, we are going to take a look at how your application is consuming memory space using JConsole. Okay, so memory consumer NetBeans project is available under samples NetBeans directory, and so you want to open that project, and you want to take a look at the properties of it. And again, we actually set max perm size 10 megabytes, and heap size is 20 megabytes. Okay. And we are going to run the application, and this is what you are going to see. So let me just run that application. So memory consumer. So if you take a look at the properties, it is already set, so you don't have to do anything. Okay. Oh, wait a minute. Is it? Oh, looks like it's not set. Okay. Yeah, so you might want to set that up. Okay, and let's just run the application. It's a GUI application. And you can add more memory. So basically, this is an application. You are just adding more memory to the application. So you're consuming more memory space. Eventually, it will cause memory out of memory exception, like here. Okay. So actual code that causes that memory exception is here is actually adding things. It's basically string buffer object, and it's just appending another string buffer. So eventually it will consume more memory space that is allowed to. So that's the reason it's having out of memory exception. All right, so just get the sense of how that application works. Okay, so this is what we just have done, and so we saw the code. Okay, and we close the application. Now we are going to use JConsole to monitor memory usage of that application. Okay, so let's run that application again. Memory consumer, and run the application. And then you want to open JConsole. So yeah, this is not what I want. So you are going to run JConsole. So JConsole is visual application. So here you need to make a connection to your JVM. So the one that we want to connect to is memory consumer application. Okay, so click that JVM process and connect. Okay, and click insecure connection. Okay, so as you can see, it has an overview and the memory usage and thread information, class information, VM summary information, and also mbeans. So we're going to take a look at these mbeans later on. So this time we are going to mostly focus on memory space. Okay, so what we're going to do is, whenever we add memory space to the application, whenever you click add more button, you're going to see this memory usage is kind of jumping up. And yeah, it jumped. There is a little bit of slack time, and again jumped. Okay, so it's normalizing it. Okay, so it's basically jumping it. Okay, so that's basically how we are going to use JConsole to see memory usage of the application. Nothing fancy. Okay. 2.4, we are going to add management capability to the application through JMX. Okay, JMX stands for Java Management Extension. Basically, you can add management, manage the object, manage the resources capability to your application. So you can get the values of attributes, you can get notifications, and you can actually invoke methods to control your application. Okay, so here we're going to actually do very simple. We're going to actually convert this application to add JMX capability, and then we are going to use JConsole to manage this application. Okay, so here, the first thing you have to do is you have to create the memory, the MX bean. So you say management factory get managed mbean like this, and then update UI is basically basically you get the usage data, and so usage data of the heap memory space and usage data of non-heap memory space. Okay, and then we are basically displaying that information. Okay, and we also want to add event handler to GC button. So there is a GC button. So you can actually go to design mode of NetBeans here. So design mode, and there is the right here. So you want to add event handler. So right click an event and the action performed. Okay. So basically, and then action performed code you want to just call mbgc. So we're going to call the GC garbage collection like that. And then when you run the application, you can see, whenever you add things, you are going to actually see the values actually being reflected. Okay, and you can also actually take a look at the mbeans so you can certainly take a look at the mbeans. So I have already provided the solution application. You're welcome to write this code and run the application or you can run the solution. So I'm going to run this solution here. Run. It is provided on the solutions directory of this hands-on lab. Okay. So now whenever I add more space, these are being reflected. Okay. Uh, the non-member, and then if you see garbage collection, yeah. Now in terms of JConsole actually connecting to MBeans, so let's take a look at whether that is something we can do. MBeans. So so we have to make a new connection. So we, which one is it? Both of them actually using the same name. So let me see whether this one is the one. Connect. MBean. No, that's not it. Yeah, by the way, we are going to actually have this JMX capability from, so I'm going to just to show you, JMX capability on any the Java application. So go to MBean. So, any Java process, any JVM has JMS features built in, meaning it has a set of attributes. For example, it has a logging features. So you can see, these are the attributes. Okay, this is Java lang. So class loading information attributes. So loading class count. Okay, so the JVM comes with a bunch of JMX capability. Okay, in our case, we can certainly add JMX capability to our application so that you can actually take a look at the attributes. You can get the notification. You can invoke some methods and things like that. Okay. Okay, so that is exercise 2. Yeah, I think we have not actually exposed those attributes from the MB. So yeah, so that's the reason we don't actually see that. Okay, so that is exercise 2. So I'm going to give you guys about 13 minutes to finish this exercise. Next, we are going to see how we can detect deadlock using JConsole. So JConsole will take a look at all the threads, and then it will detect deadlock detection. It will detect deadlock between threads. So if your application is suspected to be deadlocked, use JConsole for that deadlock detection. So it will let you know where the deadlock occurred, which threads are involved, and which thread owns and is blocked for which lock. So it gives you detailed information in terms of deadlock. Okay, so that is exercise 3. So let's see how we can detect the deadlock. So we have a sample application called the deadlock threads, and in which we have 2 threads waiting for resources from each other. So they are going to be deadlocked. Okay, so we are going to run the application, and you see some of these messages. Okay, and once you see this message, those 2 threads are now deadlocked. Okay, once they display this message, it's waiting for the resource from the other to be unlocked. Okay, so we are going to use JConsole to detect the deadlock. So we are going to select deadlock threads, and then we are going to see threads, and then we are going to click that detect deadlock. Okay, all right. So let's do that. So deadlock threads. So we are going to run it. Okay, so display. Yeah, so now we are going to, we close this guy. And okay, looks like I closed JConsole. And we are going to select deadlock threads JVM. Okay, so connect to it. Okay, so this time we are going to see threads. Okay, so these are the threads, okay, that are running at the moment. Now we are going to click detect deadlock. Okay. Now there are two threads that are deadlocked each other. So if you click this guy, you can see this is the name of this thread, pull1 thread 2, and the state is blocked. And the reason is blocked is because it's on deadlock. So this is log object, deadlock.friend. So this is the ID of the log object, and this is owned by pull1 thread 1. Okay. Now, if you go to pull1 thread 1, you see this is also blocked and is waiting for the resource that is owned by the pull1 thread 2. So they are waiting for resources owned from each other. Okay, so this is the deadlock situation. Okay. All right, so that is basically the exercise. And if you take a look at the code, it's pretty straightforward code. You know, we have a thread. We have a two thread, okay, and now we have the bow method and bow back method, and both of these guys are synchronized, and this is actually waiting for the resources from the bow back, okay, bow back this, and this is actually, you know, the so it's actually getting so this is also bow back is actually synchronized. So when this method is entered, the current friend object is locked. So in each case, the friend, so this is the log object gets locked. Okay, so the one that you're actually seeing right here, this ID, that's the friend object. Okay. Okay, so that's the end of the this presentation. And if you like to do this homework exercise, you're welcome to do it. So I'll give you guys about the 5 minutes to this exercise, and we'll move forward.